So then what is sorting? So sorting is nothing but it is an arrangement of an element in some order. It can be either in ascending order or descending order. I am not going to take the element from the 0th position. Instead of, we are taking an element from the first position. When it comes to the two-dimensional array, here we have both row and column as a combination. So when it comes to the column measure method, here our preference will be given to the column. Hello everybody, welcome back to the session 5 and 4th chapter, that is data structure. I am Rohini, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Mysuru. So in our previous session, we learned about searching of an element. So as we all know that what searching is nothing but it is a process of finding the location of an element in a linear array. So that is what we meant for searching. Then what are the methodology that we have used? That is linear search and binary search. So when it comes to the linear search, there we are going to check the element from the beginning to the end one by one. But when it comes to the binary search, directly we have access to the middle element. We are going to find the mid value by adding the beginning value and end value, that will going to be divided by 2. So that we can get the mid value. So by making use of that mid value, we are going to seek for an element, whether our element is right off of the mid element or left off of the mid element. So based on that scenario, we are going to search an element in the array. So and also we learned about some of the examples along with the algorithm. So in today's session we are going to learn about sorting the elements. So we are done with what? Traversing, insertion, deletion and searching. So in today's session we are going to learn about searching the element, how we are going to search the element, what are the methodologies we have. Along with the algorithm and examples I am going to explain. After that we are going to learn the second type of an array, that is two-dimensional arrays, and how we are going to represent that two-dimensional array and what are the advantages and what are the disadvantages we have when it comes to the array, I am going to discuss. So let me get into the today's session, that is sorting the elements in an array. So as I discussed, sorting is also one of the operations which comes under an array. So then what is sorting? So sorting is nothing but it is an arrangement of an element in some order. It can be either in ascending order or descending order. That operations or that methodology is known as what? Sorting. So there are different sorting methods we have. We have bubble sort, selection sort, shell sort, quick sort and heap sort, and we have insertion sort. But when it comes to your syllabus of your second PUC, you are just going to learn about the insertion sort. So sorting is nothing but arrangement. So there are so many methodologies or methods we have when it comes to the sorting. We have heap sort, quick sort, selection sort, shell sort, like that. But in your syllabus, you are going to learn about only the insertion sort. Then how this insertion sort will going to work? For example, I have 3 elements. Let me consider 80, 45 and 60. Is this in the sorted order? Is this in the sorted order? No. Whether it can be either descending or ascending order, it is not in any of the two types. That is, it is not also in the ascending order, even not in the descending order. So now what we are supposed to do? By making use of this insertion sort, we are going to make an arrangement of the elements. So if it is in the ascending order, it should be like 45, 60 and 80. But when it comes to the insertion sort, what I am going to do, I am just going to assume that whatever the value is there in the first position, I am going to just assume that it is in the correct position. That means it will be the lowest element when it comes to ascending. It will be the highest element when it comes to descending. That will what be the assumption that we are going to make when it comes to the insertion sort. After that, I have next element. So this element will be the key for me. So this element will be the key element for me. That means what? I am going to use that element. I am just going to compare the previous element. So in this, what I am going to do? I am just going to assume that yes, 80 will be in the correct position. And I have 2 more elements, that is 45 and 60. So this 45 will become the key element for me. And I am just going to compare this 45 with 80. So what I am going to do? Whether 45 is lesser than 80. Is 45 is lesser than 80? Yes, it is true. So when it is true, I'm just going to make a swapping. That means what? What I'm going to get now? So I'm going to get 45, 80 and 60. So this will be going to happen in the first step. So now I'm done with this first one. I have two more elements. So at this time, what I'm going to do? I'm just going to make this as a key element. I'm just going to make this 60 as a key element and I'm going to compare this 60 with the 80. So I'm just going to compare, is 60 is lesser than 80? Is 60 is lesser than 80? Yes, it is true. So that what it becomes right now? So this becomes 45, 60 and 80. So it got swapped. So now for me, it will be the last element. So this will be the last element. So if I compare this with the previous element, so this will be in the sorted format. This is how the insertion sort will going to work. First, we are going to consider any element is there that will be the correct position of that particular arrangement. I am going to make the next element as the key and I am going to compare this value with the previous one. If it is lesser than the previous one, then we are going to make a swap. Otherwise, it will be in the place as it is. At the time, we are going to leave the element and we'll move to the next element. If it is like this, so I'm just going to make this as an assumption that S45 is in the correct position. I'm going to compare this 45 with 80. So, is 80 is lesser than 45? No. So, at that time, this 80 will be in this place only and 45 will be in this place only. Then, I will move to the next one. I just make a comparison with 60 and 80. Is 60 is lesser than 80? Yes. So, we're going to swap and this become 40, 60 and 80. So, this is how the insertion sort will going to work. So, in insertion sort, the first element of an array is assumed to be in the correct position. So, we are just going to make an assumption that yes, whatever the element is there in the first position, that will be in the correct place. Then, next element is considered as the key element. We are going to consider the next element, that is second element as the key element, and we are going to compare with the elements before the key elements. What we have before the key element? That is first element. So, we are going to make a comparison between the second and first element and it will be inserted in the correct position. So, now let me show you with an example. Here, I have the array that contains 5 elements. The number of elements are 5 here and it starts from A of 0, A of 1, A of 2, A of 3 and A of 4. And I have an element 70, 30, 40, 10 and 80. So, these are the elements. So, what will be the assumption that we have when it comes to the insertion sort? I'm just going to make an assumption. Yes, this 70 is in the correct position. So, that means it will be the lowest element or it will be the highest element. That will be my assumption. So, after that, I am going to consider this 30 as my key. So, I am going to consider this 30 as my key element and I am going to compare this 30 with 70. So, that means what? Is 30 is lesser than 70. Yes, it is true. That means 30 is lesser than 70. So, that what will be the value now? It becomes 30, 70, 40, 10 and 80. So, this is what will going to happen in the step 1. At the time, next, I got to know that yes, this will be in the correct position. Again, this will become my key element. I am just going to make a comparison here. I am just going to make a comparison that 40 is lesser than 70. Is 40 is lesser than 70? Is true. Then it will be like 30, 40, 70, 10 and 80. So, this will be the second step. So, now I want to compare this with the previous element. So, I am just going to make a comparison. Is 40 is lesser than 30? Is 40 is lesser than 30? No. So, it will be as it is. I am just going to make a comparison with this one. Already we have done it. That is 40 is compared with 70. No. Now, this 10 become my key element. I am just going to make a comparison now. So, is 10 is less than 70. Is 10 is less than 70? Yes, it is true. At that time, it becomes 30, 40, 10, 70 and 80. Now I am going to compare this 10 with 40. So 10 is lesser than 40. Again it becomes true. So that it becomes 30. So these two will get swapped. 10, 40, 70 and 80. Again I have to compare this 10 with the previous element, that is first element. I am going to make a comparison. Is 10 is less than 30. Again it becomes true. Then the array value will be like 10, 30, 40, 70, 80. So now what we got to know that? Yes, 10 will move to the correct position. Already we have done a comparison between the 10 and 30, and 30 and 40 has been done, and 40 and 70 has been done. And now I have to compare, I have to make this 80 as a key element now. I am going to make a comparison of 80 with 70. Is 80 is lesser than 70? This is false. That means what? This is what the element we got is in the proper order. So that after this arrangement or after this sorting, we are going to get an element like 10, 30, 40, 70 and 80. So this will be in the sorted order. Sorted order. So this is how the insertion sort will going to work. Now we'll see with an algorithm. So when it comes to the insertion sort, what and all we require? So insertion sort is my algorithm name, and A is an array name, and N is a number of elements which is in the unsorted array. It is not in sorted. We are only comparing and we are making a sorted, so that it will be in the unsorted elements. So for I is equal to 1 to n minus 1. So as we all know that index starts from 0. But already we have assumed that whatever the first element is there in the array, that will be in the correct position. So that I am not going to take the element from the 0th position. Instead of we are taking an element from the first position. That means I am going to make this as a key element instead of taking this as a 0th position, so that it will become for I is equal to 1 to n minus 1. For example, if we have 5 element, that will be 4 iteration, that is 1 to 5 minus 1 will become 4. That will be 4 iterations will be there. So this is regarding first step. What we have in step 2, that is j is equal to I. So that means what? This will be my first index. Along with that, this will be my key element itself. So that is what they meant in j is equal to I. So for example, if I is equal to 1, then j is also equal to 1. That is what? J is equal to I. And we are going to check while j is greater than or equal to 1. Why it should be? It has to start from the first position. It has to start from the first index, so that we are going to make it true, that is j is greater than or equal to 1. The searching element, the key element must be greater than the 0th index. So we are going to assume that first element will be in the correct position, so that we are not supposed to take the first index, that is 0th index, so that it must be greater than or equal to 1. So that if it is true, then it will come here, it will going to check the condition if a of j is less than a of j minus 1. So in the previous syntax, I have 70, 30 and then 40. And we have 10 and 80. So 0, 1, 2, 3, 4. So these are the index. So j is 1 now and I is also 1. So I am just going to make a comparison a of j. A of j in the sense what? A of 1 is lesser than a of 1, a of j in the sense 1, 1 minus 1 will be 0, that is a of 0. I am just going to make a comparison. Is a of 1 is lesser than a of 0, that is 30 is lesser than 70. If it is true, then it will come here. So it will come here and we have one more variable called temp. So for that temp, I am going to copy the value of a of j. That means in the temp, my value of a of j, that is a of 1, whatever is there, that is 30. That will be copied to temporary variable, and a of j minus 1 become a of j. That means 30, this comparison will going to happen. This 30 will come out of the box. It will be like this, 70, and this become vacant, 40, 10 and 80. So that whatever the value is there in the a of j, that comes out of the box and it will be going to stored in temporary variable. And now what I can do, I can copy the content of a of j minus 1 to a of j. That means a of j is nothing but a of 1 and a of j minus 1 is a of 0. So whatever the content is there in a of 0, that is 70, that will be copied to a of 1. So in the next iteration, it will be like this. So that means this first position become vacant and this 70 will be moved to the a of 1 position and it becomes 40, 10 and 80. So now which is vacant? That is a of 0. So that is temp will be moved to a of j minus 1. So we know that we have 30 in the temp. That will be moved to a of j minus 1. So a of j in the sense, a of j minus 1 in the sense what? That is 1 minus 1, that is 0, a of 0. So what we have in temp, that is 30, that 30 will be moved to a of 0. So in a of 0 we have 30 now. So this will going to happen for all the remaining elements. So once it is done with all the element, then j will be decremented by 1. That means we are going, if I got to know that yes, this will be in the correct position, then I am not going to touch that element again. I am just going to work with a of j minus 1. So here j is equal to j minus 1, that is j will be decremented by 1 and this will become my key right now. So I am just going to compare this next element with a key element. If it is comparison is true, then it will get swapped, and after doing all these things, it will be in the sorted format, so that we are going to end the while loop. When we are going to end the while loop, when this j value becomes 0. So why? Because 0 is not greater than or equal to 1. When we reached the first value, when we got the lowest value to the first index, at that time we are going to stop the iteration. At that time this while loop become end and we are going to end the for loop. So when it reaches to the last element, at that time we are going to end the for loop. So once we got all the elements in the sorted format, then we are going to exit. So this is about insertion sort. I hope you understood insertion sort along with the example and an algorithm. So we are done with one-dimensional array. So now let me move on to the next type, that is two-dimensional array. So when it comes to the one-dimensional array, it can be either row or column. But when it comes to the two-dimensional array, here we have both row and column as a combination. That is, two-dimensional array is a collection of elements and each element is identified by a pair of subscript. So in one-dimensional array, we have only one subscript, that is only one location is there. But in two-dimensional array, we have pair of subscript. That means we have a row along with a column. So the elements are stored in continuous memory location. If it is a linear, it has to be the continuous memory allocation. That is what they meant. And the elements of the two-dimensional arrays are rows and columns. It is just like a table format. So we have both rows and we have columns. So together it will be called as what? Two-dimensional array. So the number of rows and columns in a matrix is called as the order of matrix. So how many rows we have, how many columns we have, based on that we are going to call that as a order of matrix. For example, if it is 3 cross 3, then this defines the number of rows and this defines the number of columns. That is, we have 3 rows and 3 columns in the two-dimensional array. So if it is like 5 into 3, then we have 5 rows and we have 3 columns. That is what? The order. So order in the sense the number of rows and number of columns in a matrix. So the number of elements can be obtained by multiplying the number of rows and number of columns. How we are going to get to know the number of elements in an array? So we are supposed to multiply the number of rows and number of columns. That will going to give us a number of elements. For example, if it is 3 into 3, we have 3 rows and 3 columns. That means what? 3 cross 3. So 3 3s are 9. So that will going to make us understand that we have 9 elements in the two-dimensional array. Then how the two-dimensional array will going to look like? It will be like this. So whatever is there, it will be the rows. So these are the elements of rows and this is column. This specifies the column. How many elements we have here? We have 9 elements. How we are going to get to know? Because it is a 3 cross 3. So we have 3 rows and we have 3 columns. 3 cross 3 in the sense 9. The elements will be 9. So it has a pair of indexes. So it has a pair of subscript. If I want to specify this first element, how I am supposed to specify? That is A of 0 cross 0. So this indicates 0th row and 0th column. So if it is like 1, 2. So that means what? It will going to indicate that first row, second column. Which is the first row, second column? This is the first row. Which is the second column? That is this one. So that E of 1 and cross 2. So that means this indicates this element. So this is how the representation of two-dimension will going to happen. So now we'll see how we are going to represent the two-dimensional array. So A is an array of an order m cross n. So m specifies the number of rows and n specifies the number of column. A is the name of an array. We can give any name, and to store m cross n number of elements, we need m cross n memory location. If I want to store m cross n elements, that means if for example I want to store 3 cross 3 number of elements, then I require 3 cross 3 storage space in the computer's memory. So the element should be in the continuous memory location. Anyway, it is a linear array. It is a linear type of data structure, so that it has to be in the continuous memory location. Then how we are going to represent the two-dimensional array? It can be either row major method or column major method. So when it comes to the row major method, row will be my first preference. So when it comes to the column major method, column will be my first preference. If it is row major array, I'm just going to take all the elements. So row wise. So 1, 2, 3, 7, 8, 9 and 4, 5, 6. 4, 5, 6. So this is row major. If I want to consider the column, so these are the column elements. So my preference will be given to the column values. So that 174, 285 and this one 396. So this is column major, this is row major. If it is a row major, our preference will be on the rows, and if it is a column major, our preference will be on the column. So now we'll see about the row major method. All the first row elements are stored in sequential memory location and all the second row elements are stored. So how many rows we have, based on that it will going to store as it is. So how we are going to represent two-dimensional array? A is the name of an array and it index is 0. Here also it is 0, 1 and 2. Here also it is A of 1, A of 2, A of 0, A of 1 and A of 2. So it must be square braces. So that indicates the subscript. Okay. So row major in the sense what? My rows will be my first preference. So that is A of 0, comma 0, that is 1. So if you look into this row major method, these are the addresses. So these are the continuous or contiguous memory location. So here it starts from 1001. These are all the assumed values. Okay. So there is no like 1001, it should be like that, or there is no restriction over the address. So it is just an assumption that 1001 is the first address of the element called 1, that is base address. So we know the base address. So base address is nothing but the address of first element. Which is the first element here? That is 1. How I am supposed to represent this one? That is row wise. So these are the rows. These are the rows. So that 0, 0. You are not supposed to say take like 0, 0. Anyway, it will be 0, no problem. You are not supposed to take 1, 0. Here we are giving the preference to row, so that whatever the index is there in the row side, that you have to specify. So 0, 0 will be 1 and 0, 1 will be 7. 0, 1 will be 7 and 0, 2 will be 4. So that is regarding first row. Let me consider this as R1. So next we have second row, that is index starts from 1. A of 1, 0, that is 2. A of 1, 0, that is 2. A of 1, 1, that is 8. And A of 1, 2, that is 5. So that is row 2. So what we have in the row 3, that is A of 2, 0, that is the value is 4. A of 2, 0, value is 4. A of 2, 1, the value is 3. A of 2, 2, that is value is 6. So this is how the representation of the row major method will going to happen. So let me apply all the value to this formula. So which location I want to find? That is A of 1, 2. So the location of A is nothing but an array element, that is name of an array, and I value is 1 here and J value is 2, is equal to base of A. So what is base of A? That is, we already know that base address is 1001. That is the address of first element. So that it will be 1001 plus W is nothing but word length. That is width of a memory spell. So if you consider here, we have 1001 in a continuous memory location, we have 1002. What is the gap between these two? What is the width between the memory cell? That is 1. So that W value will be 1 into, what is N here? So we know M cross N is row into column. So how many rows we have? How many columns we have? We have 3 rows and 3 columns. But when it comes to N, that is column, the number of column will be 3. Minus I minus LB. What is the I value here? That is 1 minus LB in the sense lower bound. Lower bound is nothing but first element. That is always 0. Plus J is nothing but this value. That is 2 minus LB is again 0. So 1001 plus 1 of, let me multiply. 3 ones are 3 minus 3 zeros are 0 itself, so that it will be like that. Next we have plus, so 2 minus 0 will be 2 itself, it will become 3 plus 2. So 1001 plus 1 into 5, 3 plus 2 become 5, 5 into 1 become 5 itself, so that 1001 plus 5, that is equal to 1006. So now did we got the location of this value? A of 1, 2 is nothing but what is the address of that one? That is 1006. So this is how we are going to find the memory address of any of the element. So this is about a row major. So next we have a column major method. So when it comes to the column major method, here our preference will be given to the column. We are going to write the column values first in a sequential order, so that all the first column elements are stored in the sequential order. For example, here I have 3 rows and 3 columns. So when it comes here, it is 0th column, this is first column and this is second column. How I am going to represent? A of 0, here also A of 0, A of 1, and here also A of 1 and A of 2, and this represents A of 2. So 0th column, first column, and we have a second column. How I am going to store the values of this one? First I am going to store 1, 2, 4. I am done with what? Column 1. Next I will move to the next column, that is 7, 8, 3. That is column 2. Next I will move to the last one, that is 4, 5, 6. That is column 3. So in the same way, the elements will going to be stored. That is 1, 2, 4 and 7, 8, 3, 4, 5, 6. So this represents the column. What we have in the second subscript, that represents the column, and this represents the row. So this indicates that the 0th column elements are here and first column elements are here, and we have a second column elements in the last one. That is, it will going to be stored sequentially, and we have a formula in order to find the location of any of the element with respect to column major method. So this is how we are going to represent two-dimensional array. Either it can be row major method or a column major method. So next we have an advantages of an array. So what are the advantages of using this array? We'll see now. Here I have clubbed out both applications and advantages. Application in the sense where we are going to use the arrays, and advantages in the sense by making use of that concept what we are going to do. So here it is used to represent multiple data items of the same type by making use of the single name. So as we all know that definition of an array is nothing but collection of homogeneous element, that is same kind of elements. We can store any number of same kind of elements with the same name, or a single name. For example, A of 100. That means what? All the 100 elements will be of the same type, but I am giving only one name for all the 100 elements, that will be A. So that by making use of this array concept, we can represent any number of data items of the same type with a single name. That is the first advantage. And where we can use this array, so that is regarding application. So where we are going to use an array, so that is mainly used to implement any other data structure. So we know data structure, primitive, non-primitive. Along with that, we have several types. By making use of this array concept, we can implement linked list, stack, queues, trees and graphs. So I am going to discuss all these concepts in my coming session. So stay tuned. We are going to implement linked list, stack, queues, everything, and trees and graphs by making use of the array concept. And two-dimensional arrays are used to implement matrices and mathematical vectors. So in the mathematical vectors, if you want to represent, or if you want to represent the matrices, that is nothing but what? Collection or combination of rows and columns. So that comes under what? Two-dimensional array. So this two-dimensional array will be used in the mathematical vector representation and in the matrices. So many databases include one-dimensional array whose elements are records. So when it comes to the one-dimensional array, whether it can be row-wise or a column-wise, cannot be both. So if it is like that, then we are going to call that as a records. So that will going to store n number of data elements which is of the same type. So that we are going to call that as a record. For that purpose, we are going to use one-dimensional array. So these are the advantages of an array. Now we'll see what are the disadvantages we have regarding an array. So disadvantages of array, that we must know in advance how many elements we are going to store in an array. So it is static, not dynamic. So array is static representation. So when it is static, we must specify the number of elements in the initial stage itself. For example, A of 3 cross 3. What it indicates? I am taking only 9 elements. That means 3 cross 3 in the sense I am going to multiply the number of rows and number of columns. That will going to give me the number of elements. So that 3 cross 3 in the sense 9. In advance, I must know that how many elements I am taking in an array. So that will be one of the disadvantage. So as of now, I require only 3 cross 3. But what if my requirement get changed? At that time, I have to start this from the scratch. So that in advance, we must know how many elements that it will be going to store in an array. That is the first disadvantage. So as I told, array is a static structure. That means what? Array is a fixed type. If I specify A of 3 cross 3, then it will be fixed. I cannot change in between. If I want to change, I have to start it again. So that is what they meant as static structure. So the memory which is allocated to an array cannot be increased, cannot be decreased. So once I declare A of 3 cross 3, then it has to be throughout the program execution, it has to be like this. I cannot increment the number of rows or I cannot decrement the number of rows or columns. That is one of the disadvantage. So arrays fixes size. So that means when we are creating any of the data structure, we are just going to allocate a memory space based on its data type. But what if we allocate more memory space for the specified size, then it will become waste. So that is what will going to happen with respect to the array. That is, if we allocate more memory space than its requirements, then the memory space will become wasted. This is also one of the disadvantage. So the elements of an array are stored in consecutive memory location. So it will going to be stored in the continuous memory location. If I want to change the data, or if I want to insert, or if I want to delete any of the data elements from that particular location, then that will be difficult. So that will be difficult and it also takes more time. Already I have 1, 2, 3, 4, 5, 6, 7, 8, 9. But in this place, I just want to space 100. I just want to place 100. That means what? I want to interchange the data values of that particular location. But when it comes to the array, that is static structure. So I cannot insert or I cannot delete an element as per my requirement. Anyway, it will be static and it will also be very difficult and it will take more time. So these are the advantages and disadvantages along with the applications of an array. I hope you all enjoyed today's session, and also I am going to meet you in the next session with a stack concept. Until that, keep learning, keep on growing. Thank you.